All right, turn to page 67 and let's take like structure question 25. So in this question, it says that magnesium powder, I put it into two different solutions. One is copper 2 sulfate, and the other one will be sodium sulfate, right? The question A is asked about what would you observe if magnesium is added to beaker A? All right, so let's record different color of the charge of like ions. So for example, for copper 2 plus, the color should be blue, right? And then if that is like ion 3 plus, this one should be yellow brown. So I should use a yellow brown color to represent it. And then for the ion 2 plus, this one will be pale green. And then the other two would be permanganate ion, the color will be purple. And then dichromate will be orange. So here we have copper 2, right? The copper 2 represents blue color. So I know that originally the color here is blue. So if I want to write the observations, it should be like, firstly, blue solution turns to colorless, right? This is the first step. And what else? Like if we magnesium put in it, it will disappear and the copper will come out, right? Remember the displacement reaction? The word reaction will be more reactive metal to displace the less reactive metal out, right? Now we know that the magnesium will dissolve. Magnesium powder dissolve in solution. And then what else? Copper comes out, right? What is the color of copper? Remember the table that I summarized with you before? Copper will be reddish brown, right? All right, let's go back and then write reddish brown solid, a reddish brown deposit appears. Deposit appears. Alright, so this should be the answer for A1. And then let's take a look at 2. So 2 here is asked us to write ionic equations, right? So if we write ionic equations, we should write the balanced chemical equation first. So the reaction is between magnesium and copper 2 sulfate. So copper is 2 plus, sulfate is also 2 minus. So if we do a method and simplify it, this one will be CuSO4. So let's write the balanced equation first. And later on, it will become, oh sorry, it's not Mg, this one is Cu. Later on will be MgSO4 produced, and then copper solid, right? I remember if we have to write ionic equations, we only disassemble the aqueous state, right? So this one should be copper 2 plus, that should be SO4 2 minus, right? So and for this one, it will be magnesium 2 plus and also sulfate ions. So if we take like sulfate ions here, these two are exactly the same, so we can ignore it. Then we're able to write our ionic equations. For the solid, we just copy it down. And then let's add the aqueous state of the metals left here. So it'll be Cu2 plus aqueous, and it goes to magnesium 2 plus aqueous state. Oh, sorry, this one should be Aq plus Cus. So these will be the ionic equation for the reaction occurs. Alright, let's take a look at answer B here. So B says add magnesium into beaker B, right? But the solution here is sodium sulfate. Sodium is 1, sulfate is like 2 minus. This one will be Na2SO4, right? But think about it. Is like the reactivity of magnesium is greater than sodium or less than sodium? it should be less, right? So firstly, right, magnesium reactivity is less than sodium, and thus this one cannot displace sodium from magnesium. Let me just write the symbols, would be easier. Displace sodium from magnesium. This is all about definition for displacement reaction, and I review it multiple times when I explain the videos before, so I won't explain it here. If you want to write it in the actual experiment, don't write it this way. So this way is easy for me to illustrate it to you guys. Alright, later part deduce the order of reactivity of the three metals, copper, magnesium, sodium. So firstly, we should know that the order of magnitude was sodium greater than magnesium, also greater than copper. And then all the other parts, we could use displacement reactions, right? Let me write it here. So we have sodium greater than magnesium and greater than copper. We only have the displacement reactions here. Firstly, we can compare the sodium and we can compare magnesium and sodium, right? So it's simply using the question B. If magnesium is adding to sodium, no reaction happens. Sodium sulfate, no reaction happens. It's because it is more reactive than him, right? In the second part, it could be added to copper, and then it displays the copper out. So which means this one is more reactive than copper. Similarly, for the answers, you can take a look at the mark scheme that Mr. Harris has been uploaded, so I won't write it here. That's the end of the question 25.